Hello class 9th. Welcome back. We have started with exercise 13.2 of chapter number 13 from your NCERT book. We already have done 4 questions, 1st, 2nd, 5th and 6th. Now we shall be doing a few more questions from the same exercise. Let's begin. The first question that I'm taking up today is question number 7th. Question number 7th from your NCERT textbook, page number 217. It's a very direct question. The inner diameter of a well is 3.5 meters. It is 10 meters deep. Find its inner curved surface area. Then find the cost of plastering this curved surface at the rate of 40 rupees per meter square. So it's a very simple question. You've been given the diameter and you've been given the depth. So depth of the well will be taken as the height. From the diameter you can find out the radius and then you can apply the formula for the curved surface area. Since the shape of the well is given circular, we know that well is in the shape of a cylinder. So to find out the curved surface area of the well, we will find out the curved surface area of the cylinder. Then to find out the cost of plastering, we shall be multiplying the area obtained with the cost per unit. Let's write down the answer. Question number 7th. Whatever we have given, I'm just writing it down. We've been given that the diameter is 3.5 meters and the depth, it is 10 meters. So the depth actually will be the height, which is below the ground level. So the height below the ground level is referred to as the depth. Since we need radius to use in the formula, let's find out the radius. Diameter is actually 35 by 10. Radius will be half of the diameter. So this will be half into 35 by 10. You can simplify. So this will be 7 by 4 meters. The units are same, so I don't have a problem. Let's solve further. First part, the curved surface area. The formula is 2 pi RH. Use the value of pi for the radius and the height. Simplifying. So it's 110 meter square. Second part, we have to find out the cost of plastering. The cost of plastering, 1 meter square is 40 rupees. We have to find out for 110 meter square. So 110 meter square will cost 4,400 rupees. After question number 7th, we shall be taking up question number 11th. Question number 11th. The students of a Vidyalaya were asked to participate in a competition for making and decorating pen holders in the shape of a cylinder with base using cardboard. So the students need to make pen holders. The pen holders will be in the shape of cylinders. Those pen holders will have a base and the pen holders will be made using cardboard. So if the students have to make pen holders using cardboard, they will use the cardboard to make the lateral surface of the cylinder, the lateral surface of the pen holder and the base of the pen holder. Each pen holder was to be of radius 3 centimeters and height 10.5 centimeters. The Vidyalaya was to supply the competitors with cardboard. The size for the pen holders is given. There were 35 competitors. How much cardboard was required to be bought for the competition? So what are we going to do? We shall first of all find out how much cardboard is needed for one pen holder. So that is the requirement for one competitor. Then we multiply that answer with 35. And the material required for one competitor will be given by the lateral surface because the cardboard will be used on the sides and on the base. So along with the lateral surface area, we need to take the area of the base. Let's write down. Let us first write down the measurements for the pen holder. We've been given radius as 3 centimeters and the height of the pen holder as 10.5 centimeters. So the cardboard or the sheet cardboard needed for one competitor will be given by the curved surface plus the base area, because the cardboard will be used on the sides and on the base. Now the curved surface area of cylinder is given by 2 pi RH, and the base area, because it's a circle, the area will be given by pi r square. Before I substitute the values, I am taking common factors. Common pi r, I am left with 2 and h plus I have taken pi r common, so 1 r is left here. Now I'll substitute my values. 22 by 7 multiplied by the radius is 3 in the brackets, 2 multiplied with the height 10.5 plus the radius is 3. So simplifying, outside I get 66 by 7 into, this is 21 plus 3. Simplifying further, I have got 66 by 7 into 24. So this is the material or the cardboard needed for one competitor. Now I am not simplifying this, I'm just proceeding to the next step because I want to find out how much cardboard is needed for 35 competitors. So cardboard needed for 35 competitors, this will be given by 35 multiplied with the answer obtained for 1. So 66 by 7 multiplied with 24. Let's simplify, I can cancel these. So I've got 5 into 66 into 24. So obtaining the answer, this will come out to be 7,920 centimeter square. The next question that we are going to do after question number 11th is question number 10th. Let's take a look. Question number 10th. In figure 13.12, the figure is given here. You see the frame of a lampshade. It is to be covered with a decorative cloth. The frame has a base diameter of 20 centimeters and height of 30 centimeters. A margin of 2.5 centimeters is to be given for folding it over the top and bottom of the frame. Find how much cloth is required for covering the lampshade. So this is the lampshade given. The lampshade is the covering of the lamp inside which there is the light bulb. The shape of this lampshade is cylindrical. The size for the lampshade is given. The base diameter is 20 centimeters. So the circles on the top and the bottom, they have a diameter of 20 centimeters. Height of this frame is 30 centimeters. Now this frame is to be covered with a decorative cloth. Once this frame is covered by a cloth, or a cloth is wrapped around it, the cloth will attain the same shape that of a cylinder. That cylinder formed by the cloth will have the same diameter as the frame, but the height of the cylinder formed by that cloth will be more than this frame. There will be some extra cloth on the top, some extra cloth on the bottom, which has to be folded over the edges towards the inside. To find out the cloth required, we are going to find out the lateral surface area of the cylinder formed by the cloth. For that cylinder formed by the cloth, diameter will be same, but the height will be larger than this height. How much larger? They have given to us a margin of 2.5 on top and bottom. So there will be an increase in height of 2.5 centimeters on the top and 2.5 centimeters on the bottom. So there will be a total increase of 5 centimeters in the height. Let us find out our answer. Question number 10th. The diameter is given as 20 centimeters. Since for the formula we need to find out the radius, let's find out the radius. Diameter divided by 2, this will be 10 centimeters. Along with this, we've been given the height of lampshade. So the height of the lampshade is 30 centimeters. But this will not be the height for the cloth. The height for the cloth will be given by 30 plus the extra cloth needed on the top and the bottom. So 2.5 for the top, 2.5 for the bottom. So this total becomes 35 centimeters. Since the units are centimeters, we can solve. Cloth required will be given by the curved surface area. For the curved surface area, the formula is 2 into pi into r into h. Just remember the height will be this one, not the earlier one, because we are calculating the cloth required. Use the values for pi, r and h. Simplifying, these can be cancelled. So I'm left with so this comes out to be 2200 centimeter square. Now after this we are moving to question number 8. Let's take a look at the statement. Question number 8. In a hot water heating system, there is a cylindrical pipe of length 28 meters and diameter 5 centimeters. Find the total radiating surface in the system. Now this is important. Although they are saying that you have to find out the total radiating surface, don't get confused with the fact that they are asking for the total surface area. They are not asking for the total surface area, because the object for which you have to find out the area is a pipe. It's a cylindrical pipe. The pipe is open at both the ends. It is not closed, so we cannot find out the total surface area. We need to find out the curved surface area. Now let's just look at the fact why we need to find out the curved surface area. In the water heating system, the surface that heats up the water is the pipe itself. The water is running through the pipes. The system heats up the pipe, and the pipe in turn heats up the water. So when the water is traveling through the pipe, it comes in contact with the curved surface area of the pipe. And that is what actually causes the heating of the water. So to find out the total radiating surface in the system, we need to find out the curved surface area of the pipe. Now to find out the curved surface area of the pipe, which is a cylinder, the length is given and the diameter is given. Let's just draw a rough picture for this. Question number 8. Now this is how the pipe would be. The length of this pipe is 28 meters and the diameter across is 5 centimeters. So this is the diameter and this is the length given. So if we are considering this pipe to be a cylinder, the length actually is the height, because we represent the cylinder perpendicular to the ground. The height is always perpendicular to the ground. The circular ends are on the surface. So H for this pipe is the length. So height for the pipe will be taken as the length of the pipe, and the diameter is 5 centimeters. From here we can find out the radius. Radius will be equal to 5 by 2 centimeters. Now there is another thing we need to keep in mind. The units for the diameter are centimeters. So our radius is in centimeters, but the height is in meters. So we need to convert. So let's convert this. Converting meters to centimeters. So this becomes 2800 centimeters. Now we need to find out the total radiating surface, which will be given by the curved surface area of the pipe. Let's solve. So the total radiating surface, again I'm writing the word total, but I will not be calculating total surface area. I'll be calculating the curved surface area. Two facts, because the pipe is open at both ends and the surface that actually causes the heating of the water is the curved surface of the pipe, which is given by 2 pi r h. Let's use the values. Pi is 22 by 7 because we have not been given any other value in the question. The radius we have calculated as 5 by 2 centimeters. The height is 2800 centimeters. Let's simplify. The total will be in centimeters square. 2 and 2 cancelled. 7 can be used to cancel this. So this comes out to be 22 into 5 into 400. This comes out to be 110 into 400. So this will be 44,000 centimeter square. If you want, you can convert the answer into meter square, because at the back of your textbook the answer is given in meter square. So let's convert, and this will be kind of practice for you. If you remember, 1 meter square equals to 10,000 centimeter square, and we are converting the smaller units into the bigger ones, so we'll be dividing. So 44,000 divided by 10,000 meter square. So once you divide by 10,000, the units get converted, and these 3 zeros get cancelled with these 3 zeros. The 10 can be used to introduce a decimal, so the answer comes out to be 4.4 centimeter square. The next question that we are going to do is question number 4th. Now question number 4th is a question which you have done last year as well. You probably remember, it's about a road roller. Let's take a quick look at the statement. The diameter of a roller is 84 centimeters and its length is 120 centimeters. It takes 500 complete revolutions to move once over to level a playground. Find the area of playground in meter square. Now there is a note that I would like you to write down before we start with this question. Write down a note. There are two facts about a cylindrical object. Once a cylindrical object rolls over, the cylindrical object rolls over a surface, its curved surface comes in contact with the ground. So if you imagine the road roller, rolling on the ground, or if the road roller is being used to level a ground, its curved surface comes in contact with the ground. Now when the curved surface comes in contact with the ground and the road roller is moving, it's continuously turning and moving forward, there is a distance covered and there is an area covered. There are two things. When the road roller moves, there are two things that are covered by the road roller. If its movement is measured in a single dimension, then we are talking about the distance that it covers when it makes revolutions on the ground. And second thing, when it is making revolutions on the ground, when it is turning over and over, it covers a certain area. Now how do we find out the distance covered or the area covered by a cylindrical object like a road roller? Another example could be a wheel. So the note is with respect to that. So let's write down. The first fact that we want to note is the distance covered by a cylindrical object Now what could be those cylindrical objects? You could write down for yourself like wheel or a road roller. And the distance is covered when the roller or the wheel is moving, and when they move they make turns. Those turns are called as revolutions. So when they make one turn or one revolution, and this is actually a complete revolution, the point which is in contact with the surface comes back in contact after one complete revolution. So this is given by the circumference of the base. And second fact is, now this is distance is one dimensional, same is for the circumference. If we find out the area covered by cylindrical object, in one revolution, this will be given by the curved surface area, because when a cylindrical object rolls, its curved surface comes in contact with the ground, and that is what actually levels the ground. And both of the concepts you have used. This was used by you, I think, in 7th standard. There was a question that there is a wheel which is making revolutions. The size of the wheel was given. In terms of its radius. You had to find out how much distance does it cover after it makes a certain number of revolutions. So to find that, what you do is you find out the distance covered in one revolution. You find out the circumference, and then you multiply that circumference with the number of revolutions to find out the total distance covered. In 8th standard, you come across the curved surface area of a cylinder, and you had a similar question where there's a road roller which is turning over and over, making certain number of revolutions, and you have to find out the area covered by that road roller. And what you do is you first of all find out the area covered in one revolution, which is given by the curved surface area, and the total area covered will be given by the curved surface area multiplied with the number of revolutions. And this is what we are going to do in this question. Let's write down the answer. Question number 8, the solution. Let's note down the measurements. The diameter is given as 84 centimeters, and the length of the road roller is given as 120 centimeters. Now the length for the road roller is actually the height. Because if the cylinder is lying on the ground, its height gets converted or appears to be the length. So if I hold this pencil vertically, right now this is the height, and if I just put it down, it will be the length. So same case, height is 120, so the units are same. We need to find out the radius to be used in the formula. Dividing the diameter by 2, 42 centimeters. Okay, I missed one thing. If you read the question at the end, they are saying that the area needs to be calculated in meter square. So there are two options. Either you can convert these values right here. You can convert these values right here into meters and then calculate your answer. So that is option number 1. So either change the values now, or what you can do is you can change your answer once it's obtained in centimeter square. So whichever way you want to do it, you can do it. I am calculating the answer in centimeters. I'll be converting it at the end. So let's find out the area covered by road roller in one revolution is given by the curved surface area, which is equal to 2 pi r h. Let's solve. The radius is 42 and the height is 120. So because both the values are in centimeters, the answer for the curved surface area will be in centimeters square. I'm not simplifying, I'm moving further. From one revolution, I'm going up to 500 revolutions. So in 500 revolutions, what will be the area covered? So this is the area covered in 1. This will be multiplied with 500. 500 multiplied by 2 into 22 by 7 into 42 into 120. Let's simplify. These can be cancelled. So this is 500 into 2 into 22 into 6 into 120. Solving. This is 1584 with 4 zeros. and since this is the answer in centimeters square, but I need the area of playground in meter square. So let's find out the area of playground in meter square. This will be the area that I've calculated, which is in centimeter square, divided by, so this is the area which is in centimeter square. I'm converting it into meter square. I'll divide this answer by 10,000 and this will be in meter square. We did the same in the previous question also. So these 4 zeros get cancelled with these 4 zeros and I'm left with 1584 meter square. That's the answer for question number 4. Kindly note it down that this is important type of a question.